All right, ladies and gentlemen, time for the rubber to hit the road. In this video, we will finally see how we can use the techniques that we have to take a polynomial and find all the zeros and all the factors. Here's an example of a quartic, degree 4, and by the fundamental theorem, we should have how many? That's right, 4 zeros. Possibly 4 linear factors as well, although we'll see that that's not always the case. The steps that we will outline in this video go like this. We will first look for the integer zeros, the nice ones. And here we'll use the table, or actually in this video, we're going to look more at the graph. Okay? But we're really going to look for those nice zeros that are obvious, and we'll make full advantage of those. We're going to take those zeros and write them out as factors. And the more nice ones we have, the more factors we'll have. If that doesn't give us all of them, so if we're missing some, we will use division by the nice factors to find the not so nice ones. Okay? And so we'll see how that's going to work out. Alright, so let's get started. How do we find these zeros and the factors? Well, we'll start by looking at the graph. And right away by looking at the graph, we can tell several things. One is we can tell that all 4 of the zeros that we're looking for are real numbers. And we can tell because we see 4 x-intercepts. So that's good. No complex numbers here. But in particular, we can also see that 2 of them, so this one right here is -1, and this one here is +2. Okay, so that one right there and that one right there are nice numbers. Okay, they're -1 and +2. But the other 2, this one right here and this one right here, so those are right next to each other. Those are decimals, and we don't really know what they are. But I'll show you how to find them. So we start by changing these x-intercepts into factors. Okay, so the -1 gives us an x plus 1, the 2 gives us an x minus 2, and these last 2 here, they must come from what's left here, which is some sort of quadratic. Okay, so some quadratic. And this quadratic may or may not be factorable, we're not sure, but we know it's a quadratic because we're looking for 2 more solutions. So how do we find that quadratic? Well, division. So we need to do some division here to find out what that quadratic is. So we'll set up our division. So we'll start with an x to the 4th here, and we'll need 4 columns because it's a quartic, and so our 6 is going to go down here. And just like what we did before, we'll have 3 groups of like terms. Those first 2 will add up to x cubed, sorry, negative x cubed, and then negative 5x squared, and then finally 3x. And you can divide by either one of the factors in any order that you like, and so let's divide first by x plus 1. Alright, so here's how the division goes. So x cubed times x is x to the 4th, and x cubed times 1 is x cubed. But to get negative x cubed, we need negative 2x cubes here. And that means that this has to be negative 2x squared. Times 1 is also negative 2x squared. But to get to negative 5x squareds, we need 3 more negative x squareds up here. That makes this negative 3x times 1 is negative 3x. But to get to positive 3x, we need 6 x's up in here, leaving us with a 6 times 1 is 6. Check. So when we divided this quartic by x plus 1, we ended up with this cubic. Okay, so our degree got decreased by 1. Now we're going to take that cubic and divide it by the other factor, which is x minus 2. So we're going to divide that by x minus 2. And since it's a cubic, we need 3 columns, so the 6 is going to go here. And again, here are our like terms. This one is going to be negative 2x squared, and this one is going to be negative 3x. So, let's see, x times x squared is x cubed, and x squared times negative 2 is negative 2x squared. Oh, look, that's all we need is negative 2x squared, so we don't need any more x squareds in this box. That means that this must have been 0x times 0 times x is 0x squared, and 0x times negative 2 is also 0x. But since I need negative 3 x's, they all must have gone here. And that means that this is negative 3 times negative 2 is 6. Check. So that means that the quadratic that we've been looking for is right there. That's x squared minus 3. And that is going to give us our last two x-intercepts. Okay, so when x squared minus 3 equals 0, that means that x squared equals 3, and x is plus or minus root 3. So root 3 goes here, negative root 3 goes here. In fact, since root 3 is about 1.7, do these two x-intercepts down here look like they're about like 1.7 and negative 1.7? I would say so. Okay, so now we know exactly what those two are, and now we know exactly what the factors of this quartic are. The factors are x plus 1, x minus 2, okay, those are the linear factors, and x squared minus 3 is the quadratic factor that gave us the other two zeros. Time for you to practice. This is exercise 13 in your packet. There are 6 polynomials here. Remember, for each, the degree tells you how many zeros you are looking for, and so your goal is to find all the zeros and all the factors. If you do the first 3, that should be really good practice. 4, 5, and 6 will add a little bit more insight, but try and at least do the first 3 really well. All right, well, we're going to go through the 6 solutions and check your answers as you go along. Here we go. All right, number 1. So the first thing you're doing is you're graphing it on your calculator, and you'll notice here that the x-intercept is, there's only one, is at positive 1. And notice that since we're looking for 3 of them, the other 2 must be complex. Oh boys, so don't worry, don't fret. What that means then is that, oh, don't want to show you that yet, that one of the factors here must be x minus 1, but the other factor, which is a quadratic, we'll get by division. So divide the x cubed here. Here goes the negative 5. These 2 add up to 3x squared, and these 2 add up to x. So the division goes like this. So here's x squared times x is x cubed, and x squared times negative 1 is negative x squared. To make 3, we need a 4, x squared here. So this is 4x, times negative 1 is negative 4x. But since we need a positive x, this must be 5x, and this is 5. 5 times negative 1 is negative 5. Check. This then is our quadratic factor. And so the factorization is x minus 1. Okay, that's that first factor that we got right here. That gave us an x-intercept at 1. And this quadratic factor, which we got by division, and this is going to give us two complex zeros. In fact, so x squared plus 4x plus 5, if we use completing the square, we completed the square here with the 4, factored the left side, took the square root of both sides, and there's negative 2 plus or minus I. Those are the complex solutions, the zeros, and therefore those are the three right here. These are the three zeros of that polynomial and its factors. You would also get the same result by using the quadratic formula as well. All right, time for there we go. Time for the second one. This one is a quartic, and therefore we're looking for 4 zeros. So we look at the graph, and sure enough we see 1, 2, 3, 4. 4 real solutions, so no complex here. That one looks nice at negative 3. This one looks nice at 2. But these two seem to be decimals. So we need to do division. And let's see, which one will we divide by first? Oh, so this one would give us a factor of x plus 3, right? And this one would give us a factor of x minus 2. So let's pick one first. Let's do the x minus 2 first. So our quartic is 6x to the 4th. And then the 6 goes down here. And then my diagonals are going to be 7 x cubed, negative 36 x squared, and negative 7x. And let's divide. So up here I must have a 6x cubed times negative 2 is negative 12x cubed. But to get to 7, I need to add 19. 19x cubes. That's a big number. Up here then, I need 19x squareds times negative 2 is negative 38x squared. But to get to negative 36, I need 2 positive x squareds, which means this is 2x times negative 2 is negative 4x. To get to negative 7, then, I need 3 more negative x's up here. So this is negative 3 times negative 2 is positive 6. Check. So I've reduced my quartic to a cubic. Now I want to divide the cubic by the other factor. So I did this one already. So now I'm going to divide by the other one. I'm going to divide by x plus 3. And it's a cubic, so I only need 3 columns. There's my 6x cubed. Here's my negative 3. And my diagonal sums are going to be 19x cubed and, 19x squared. There we go. And 2x. So, start up here. 6x squared, which times 3 is 18x squared. But to get to 19, I need 1 more x squared. So this is just x times 3 is 3x. To get to 2, I need a negative x here. And so this is negative 1 times 3 is negative 3. Check. So here's my quadratic that I will need to get the other 2 x-intercepts. So that quadratic is equal to 0 when, and here you can see that I'm factoring it this time. And by factoring it, I can see that those two x-intercepts are, right here, are negative half and positive 1/3. So, here's my factors. These are all my factors. The x plus 3 and the x minus 2 I got from the graph. And the 2x plus 1 and the 3x minus 1 I got from down here. Okay, so I have 4 linear factors because I have 4 real zeros. And right there they are. Those are my 4 real zeros. And number 3. Once again, we have a quartic. And so again, I'm looking for four real zeros, or 4 zeros, but I don't know if they're all real. And in fact, looking at the graph here, I only see one x-intercept. But if you know anything about polynomials, you'll recognize that this so it's at -1, but it has multiplicity 2. So the factors that are associated with this are x plus 1, but there are 2 of them. So squared. And that means that we're going to have to divide the quartic by x plus 1 twice. So x plus 1, and then we'll do it a second time. Okay? So here's my x to the 4th, here's 9, and my diagonal sums are 2x cubed, 10x squared, and 18x. So we start dividing. Change colors here. So x cubed times 1 is x cubed. To get to 2x cubes, I need another x cubed. And that makes this x squared. X squared times 1 is x squared. To get to 10, I need 9 more x squareds. So this is 9x times 1 is 9x. To get to 18, I need 9 more x's. And so this is 9. 9 times 1 is 9. Check. So now I've reduced my quartic to this cubic. So now I divide again. And we're going to divide that cubic by x plus 1 again, because remember there were two factors that were the same. So here's my x cubed, here's my 9, and my diagonal sums are x squared and 9x. So we'll divide one last time for this video. And alright, so listen. So this is x squared times 1 is also x squared. I already have an x squared, so I don't need any more x squareds, which means that this was 0x. Times 1 is still 0x. And to get to 9, I need 9 more. And so this is 9 times 1 is 9. There we have it. There's our quadratic factor. And that's going to give us the other 2 zeros. Okay, so we saw that -1 counted for 2 of the zeros, but we were looking for 4, so this is going to give us 2 more. So then x squared equals -9, and x equals da 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 da. That's right, plus or minus 3i. They are imaginary, just as we expected, because we didn't see any other x-intercepts. Our factorization then is going to have our x plus 1 squared, which we got from over here, and our x squared plus 9 is our quadratic factor that we got from over here. And this is quadratic because it had complex zeros. Notice that we have 4 zeros, the -1, that's repeated twice, and then 3i and -3i. The second set of 3, I'll go through more quickly. Take a look at number 4. There's the graph, and here you'll notice x-intercepts at 1 and at 5. And the one at 1 is actually has the characteristic of multiplicity 3. Okay, and so since it's a quartic, and that one counts for 3, and the 5 is one more, then all 3 of those, all 4 of those are real. And so the 1 is repeated 3 times, the 5 is the 4th factor, and so there's our factors and our zeros. And you can check to see that this is really the way to factor it by graphing both on the calculator. And here no division was necessary. Number 5. This is a quintic, so I'm looking for 5 zeros, and there I can see 3 of them. So unfortunately here we'll have to divide twice. Sorry, no, not twice. 3 times. And I will spare you the details. You can do it on your own. Notice that if the x-intercepts are -2, 1, and 2, then those are the 3 factors that you'll need. And when you divide this quintic by all 3 of those, you end up with this quadratic at the end. And that gives us this lovely pair of complex solutions. Number 6 looks like this. 3 real zeros, although only one of them is nice. So -1. And if we divide that out of the cubic, we're left with a quadratic, and therefore there's our 3 zeros. I hope you learned a few things. Come to class with questions. As always, it's been a pleasure.